Good afternoon, everyone. All right, so let me recap. We're going to have Nikhil take us through the year-end release of 11.x of the electric vehicle and autonomous vehicle platform that Omnex has. The platform has been used by many companies currently for managing their requirements, all the way down to integrating most of the work products and artifacts that we have. Of course, it goes without saying that just not in silos, but requirements management in terms of problem resolution, change management, configuration management, so on and so forth. There's a lot of things that the EV platform does. And I hope Nikhil would be able to give us a glimpse of what is in store for us in the next 2 months. Just to give you a 1 second introduction about Nikhil, because I don't want to introduce the same guy 2 times in half an hour. Here's Nikhil.
Thank you, Arun. So I bribed them to put a break right after Sabu's presentation, just so that we get a stretched legs and everything. All right. So when we were thinking of this topic, right, we had, you all know that we have a few different platforms. We have a QMS platform, we have a supply management platform, and we now have the EVAV platform, third one being discussed. So we were thinking about the title, features released in SP11X and later. Okay, that's what we were thinking. But then we went back and thought a little bit more. So QMS platform, and Chad has mentioned this, Anthony has mentioned this, it's been mentioned quite a few times. I think 1984, sometime when, with the University of Michigan, there was a professor who helped Omnex implement the linkages between the DFMA, PFMA control plans, the first of its kind. That's when AquaPro started to roll out. So since then, AquaPro has been there. So it's a module that has been matured and weathered over a lot of time, used globally by so many Fortune 500 companies, right? And then as we've expanded into new horizons, EVAV, as you all seen, electrification, autonomous driving. So that's been another frontier that we are trying to, again, help make it digitalized through our software solution. So today, I do understand a lot of you are also new to EVAV platform, all of this, what it can do. So it's not just what features we're coming out in the next 2 months, but also what the whole platform can do. So we're going to show you that as well. So for those of you who are new to you, don't worry, you don't have to, I need to know what was until 11x to know what is the new stuff. No, even if you're new to all of this, you'll be able to understand the whole presentation, okay? All right, so majority of the presentation is going to be through a video that I'll walk you through, where we have the functioning software showcased, and I'll talk to you about the use cases. So the flow is going to be, again, 4 steps: challenges in the industry, introduction of the platform, and we'll talk about how the platform works, and then key takeaways. You've been seeing this slide quite a few times. I brought the same thing yesterday. I know Chad showed it in his presentation today morning. It's just like one of those, I think the arrow slide we were talking about the other day. It's like if we have a conference, at least the same slide should be used 4 times, right? But why? Because it's very important. It's a key takeaway. If you look at this slide, I hope next year we don't have to bring it up again. You all remember the number 434 work products. If you integrate it, it's about 200. So saves time, more efficient, right? So with that, plus, if you look at the distributed design supply chain, I got my engineering team in India, China, and maybe Europe, and then another one in North America. I also have different plans in different parts of the globe that's helping make these products. How can I make all of these more streamlined? How can they all talk to each other better? That's the whole purpose of this digitalized solution. So, I mean, we are all familiar with the different standards. I mean, I see most of you here, all of you have like a couple of decades of experience, at least under your belt. But talk about your same organization that is having more younger talent. How are you able to have those lessons learned carried forward? And how are you able to incorporate those best-in-class practices to the next batch of engineers coming up? That's where some of these digitalized solutions help. And also at the same time, everybody's working on the same platform. So there's no my Excel worksheet on a Google Drive versus another Excel sheet on SharePoint, right? It's all one single place. So to make all of this happen, that's been, I think, the overall vision of what Omnex Systems is trying to achieve. And through this EV/AV platform, we are going to, again, specifically help organizations involved in anything with electrification and also autonomous driving. So as we said, the design supply chain, there's tremendous exchange of information, forms, checklists, all of that is not possible without technology. Simple thing, there's a form, I want to have revision controlled. If I have 5 different locations, how can we make that happen, right? Everybody's working on a different version. So now I'm going to talk about what the EV/AV platform has for you as a solution. So you look at the 4 different platforms here that we have here on the screen, and this is the one this is the EV/AV platform. So for some of our customers who've been with us for a few years, we used to be in a modular approach in the past. Like we used to have these modules, but then we've navigated to the platform which offers it as a solution. So you don't have to specifically talk about one module, another module. It's about, I have a problem. How can the software help me solve that problem? So Srinath, Madhu, and Sabu has already explained about the QHSE and also the supply management platform. And also Andre in the morning covered the PQP platform as well, right? So in the EV/AV platform, how does that function and what's the key part of all of this? Let's take a look at this. So you've seen on all the way on the right-hand side here, there's something on timing. So yeah, timing's there in every area. Anything you are developing new, there's always going to be some program management involved, right? How can we leverage that? And then we got integrated DFMEA, DVPNR, process flow, all of those things that we've always had for quite a few decades now. So that's again being used. If you're talking about functional safety, you got part 7 covering that. And similarly in cybersecurity, you also have manufacturing as well. Right? Same thing with HARA, getting to the ASIL goals, all of that, again, significant. So I'm not going to go through each of these icons and explain, but I'm telling you there's a lot of shared practices between the standards that you can leverage. So it's not like something new that all of these are coming up with. It's just that there are some technical ways to do it, but there's also methods from the past you can leverage. Right, DFMEA, it's been there, it's not new, but you can use it for functional safety, right? So things like that. So in this quick view, I'm going to leverage what Marcus presented in the morning. So Marcus from Bosch had this diagram, another version of this diagram up on his slide. So he took us through functional safety. And of course, because I don't have 2 days to explain all these 3 different standards, I'm going to use functional safety as my base, and I'm going to walk you through it. So starting all the way from safety plan through item definition, HARA, technical safety concept, safety analysis in parts 4, 5, 6 of 26262, through the V&V, and then you're getting to the audits and assessment for the safety case release. And then we go into the release for production. This is what I'm going to show you in the software. Of course, I had it recorded just in the interest of time so that you don't have to see me move my cursor and everything. So this is what I'm going to show you right up, okay? So. All right, so this, Sabu mentioned this, that we've shown the platform landing page many different times. But how is this one different? So let's talk about it. The way is the data that people are interested to see in it is different, right? We have, when I'm looking at it from a QHSE point of view, the type of metrics I'm seeing is a little different than when I'm looking at it from a point of view of a product designer, program manager. So different people have different pieces of information they want to see. So I'm showing you these widgets on this landing page, which serves as one single place for the users to come and see key information that they need to really focus on. So the software has these different functions, and what are we trying to solve here? Siloed softwares, right? So what can the EVAV platform offer as a solution? Single place to see everything. Where is a single place to see everything? The landing page. So our objective is less number of clicks, get to the data that you need to get to. So that's what this landing page has to offer. So you're seeing the showing you here the safety / cybersecurity ASPICE plan. And for those of you who know these areas, again, it's talking about what are my deliverables in functional safety or cybersecurity or ASPICE. That's going to be different in content, but project management is pretty much same across industry. Like Project Management Institute, PMI has guidelines. I'm using the same guidelines across the board, but what I'm managing changes, right? So you have common things like that. So we're going to use, like I said, functional safety as an example and demonstrate that to you. So here we are showing some key tasks that this user has pending up, even some upcoming meetings, and then the V model. Andre covered on the V model as well earlier. You can also have project risks that are affecting the program. That's shown there. And then, of course, the requirements. Let me just try to get rid of this. There we go. So at the end of the day, when you have all of these different projects running in the organization, let's say you have about 9 different functional safety projects running. So how can you see the status of completion of those projects? That's what we're showing here to you in the dashboard. So here we have our different 9, let's say, different projects. I'm going to take the example of a battery pack safety plan. Opening up that, I'm seeing the different phases that is there within the project. Tying this back to APQP, we have the 5-phase APQP, right? But in functional safety, you have different phases. You have concept phase. You may have, let's say, systems development phase. You can, again, tailor it to your organization's phases. I'm just giving you as an option. So here, I'm just going to filter it by, let's say, the one of these phases that we have showing to you right on this area. So we've selected the concept phase. Now going into concept phase, you're seeing all of these work products or artifacts that's being shown. So you have the status, how many of my work products are completed? So did I assign my safety manager? Did I get my program plan completed? Did I get the DIA sent out with the customer, and maybe one you have with your supplier as well, right? So these are things that we are looking at, and status of each of those. So now going into the actual program itself. So we're going to take this same safety plan that I showed you earlier and then deep dive into it. So everything in orange you're seeing are the gate reviews that you have. And then you have the mouse pointer that is trying to open up one of those phases that you have. So you have the phases with milestones inside each of those, right? So now let's say you're going to the general phase and you're seeing each of these activities. This is what I had done the reporting earlier for you and saying, well, did I assign my safety manager? So you can see there's one of those tasks. Did I get my DIA sent? Yeah, was that done? So it's sourcing information from here so that in a dashboard, you're getting all of this in one single view. Now, when you're getting into concept definition, you're talking about like your item definition there. You got your functions, requirements, architecture block diagram, interface function metrics. So if you look at this, this is everything that you must do to get your item definition done. So next time somebody is asking in your functional safety journey, did you get your item definition done? Well, my block diagram is halfway there. My requirements are halfway here. No, all you have to do is just check how much of this is done and which version they are at. All right. Of course, there's going to be iterations like Marcus showed in his Safe Ops presentation. There may be new deltas that will come that we have to incorporate into the product. But do we have a baseline to start everything with? That's the first question. Okay, now then when you go further, we're just showing you some other phases again on the screen. So here you can see the other phases. So what's unique here? You're talking about product development at system level and integration and validation, product development at hardware level. Same thing. You see, it's again something you can leverage between different standards, right? Now, this is very much more towards functional safety, but cybersecurity too, you can do it. Now, you might be wondering, oh, well, I've seen this. what's so unique about this? It's a program management, it's a Gantt chart, I use MS Project. How is this different? Anything different than me? I mean, first and foremost is this is one place that everybody has to come and see the status of the program timing and completion, right? I don't have it as an MS file in my local system or something. Second thing is work product management, which I'm about to get to. Everything that you see a paperclip icon on the fourth column from the left, that shows that there are artifacts, work products, or records attached to it. So when I'm opening up my functions and requirements here, it takes me to a page that has the voice of customer serving as an input, and also there's an output document. So what is that? You're talking about digital forms embedded within the software. So this is not like a PDF or an Excel document or a PowerPoint that I'm just uploading. Instead, these are live digital information. So how does this help? When you're getting to your next program, you have your reuse cutoff. So if I have a sensor I'm designing, I want to make my version 2 of the sensor, I can reuse this information and leverage that for my next iteration. So you have the requirements document. Again, what we're showing you is just a template. You can add your own custom columns and tweak it to your tailoring needs. But this is showing what the key functions and requirements are for that particular product, status of approval, which elements the requirements are being allocated to. If I'm designing, let's say, a big battery pack, I have my subsystem, my components, where am I allocating all of this to? And then the status of review, that's also being shown here, right? So you have, again, traceability through the identification that, of course, the numbers are assigned by the system. So you can, again, take each of these individual requirements or a batch of requirements like a feature and send it through requirements review and approval, and so that you can have it reviewed by your peers inside the tool. So your input, the main thing is that's your live document. That's your live document that people are working on. Output. So output is, what are you publishing? What does your version 1 of your requirements say? That's your baseline. This is going to feed into your configuration management and saying that, okay, this is my version of requirements that is coming out in version X of the product. And again, each work product will have that. So keep in mind, in this, we are showing you that all this template changing creation, you can digitally control that. So that a lot of these forms that we're using, it's going to be digital. So it's going to be inside the tool. Now, of course, we're not going to have everything. There will be certain things that you may still want to do, like a Word document or something like that. You can still have those kinds of work products there too. Here's your revision history against the work product, showing the different versions, who approved it, when was it approved, all of those key questions answered one single place. And then here, I'm showing you block diagrams. So we're talking about a place where you can have the block diagrams created inside this. Now, it might look like a simple, I could do this in PowerPoint too, like put the squares. How's it different here? The difference is each of these blocks that you're talking about is informational items. It's like a block that contains a lot of documents. So everything that you're seeing a box here is a box, it's an element. Talking in the terms of functional safety, you have item and everything below that is element, right? So you have the item, which is the big blue box containing all of these small boxes, all of your elements. So here, the value is, once you update some of your work products here, related work products also update. So how does that happen? I'll tell you with one example. You change these blocks, your allocation metrics will change. Your requirements will change because I'm drawing lines between these blocks. Those are my interface functions and requirements. So your interface functions and requirements are also going to change when I'm changing, let's say, from a solid line to like a dotted line. The type of interface changes could be like physical versus electrical or whatever those are, informational or data transfer, for example, as being another interface. So you could have those change. And then same way, if you add the elements and remove it, it's going to affect other work products, which we'll get to in a couple of minutes. So the advantage is I don't have to update related artifacts twice. You're updating it once. And then, of course, here's the interface function metrics that I was just talking about that contains a list of functions and requirements. And I have to pause here to just explain that point to you. So everything you're seeing with the green background is not populated by a human. It's populated by the system anytime you're drawing a line. That's your interface function requirements. And then you got your elements at the top right-hand corner that is showing what those elements are. That is part of your architectural diagram. So you have your functions requirements, and again, your interface allocations being performed there. Now, for those of you who have a lot of automotive experience already, interface function metrics has been something that has been used in the past too. It's not rocket science that just came out yesterday, right? It's been something that's been leveraged for quite some time. So that's, again, how can you integrate these artifacts and leverage your existing automotive practices into these new compliance obligations you see as functional safety or cybersecurity, etc., right? And then, of course, we are talking about dynamic systems. So you even have like state transition diagrams, P diagrams, all of those that you could do there as well. And then we can go further down into again, we'll show you some of those other attachments. Like here, I'm opening up the HARA. So when we're talking about the HARA, you have the HARA, that is the actual work product itself, and then the review that comes in after that. So here's your HARA that has what we call as the operational situations, and then the malfunctions and the failure modes. So when you're doing the HARA, you're going to create a library of operational situations. Is my car going on the highway? Is my car going on the urban? If I'm doing an off-road vehicle, my operational situations are a little different than what I'm doing like a sedan or a city urban car, right? So you're going to put all of that, becomes your library, and then you have severity, controllability, and also exposure that was there earlier in another column, and you get your ASILs leading up to the safety goals. Again, all of this is done inside the tool. I'm not doing it like in an Excel and uploading it. So it's a library that's going to be controlled. And here's an example. This one is more like a live document. It's like an Excel document that's embedded inside it, but this is showing review. So if you're familiar with, again, functional safety, I think this is coming from part 3. It's in the appendix where they talk about confirmation review checklist. The same checklist has been used and filled out. So similarly, you have work products, you have reviews, you have control on those work products as well, right? Now I'm going to take you to the area where these artifacts are actually created and controlled. So that's the next stage. So here, these are places where these work products are actually created inside the platform. So here, for example, I'm going to go into again, you can see the list of all of those. I'm not going to go one by one, but for example, we're opening up the Mercury battery pack system. This is only one of the products. You could have many different products that you're designing within the organization. So here's your library of operational situation. This has been leveraged to come up with the HARA. Okay, so this is where you can, again, control that information, how you can change the exposure values. And for example, simple things like I can't put a low exposure value without a rationale, right? Things like that. So those are controlled by the tool. And then you have your requirements against which you have your failure mode. You have a list of malfunctions that can be leveraged to come up with those failure modes. And here's your final safety goals. So the key thing here is different lines of the HARA might come up with different ASIL ratings. But I could put the same safety goal there too. But at the end, the safety goal gets the highest value out of the multiple assignments. So that's what this is a comprehensive list of, well, HARA I have, let's say, 100 lines, but this is my 6 safety goals or whatever that number is. So this is the safety goals with the ASIL ratings, the safe states, and the FTTI or the fault tolerant time interval. And so that's what you're seeing here. Now, moving on, the next stage will be going into the functional safety concept. You have again, this is part 3 of the standard again. You have your preliminary architecture, you had your functions and requirements. Now, how do you take that safety functions and safety requirements and allocate it to the architecture. Maybe you need to go and revise your architecture once more. That's going to be your revision 2 if you do it. So here's your safety functions, safety requirements, and then here's how you're allocating it to the battery management system. So you can see some requirements are ASIL-B, something is getting allocated there. So again, these are examples being shown. Keep in mind, we're not showing any confidential customer data. This is just something we put together for you all to see. So here's your structure. And then in the tool, you can drill deep into any level of the item element structure. Like here, I have the battery pack that's been made up of 4 main level subsystem, battery management system, module, mechanical enclosure, and module balancing unit. But inside the battery management system, I have the hardware, software, and all of these tiny electrical hardware components that is inside it. And again, the software can also go. Here's all the way going to a 32-bit microcontrol unit with all of this. I know Emil helped me in the past with this example, the standard 32-bit MCU, Emil. So we're just showing you how you can go from one level of the requirements again to the next level, and then you're allocating into the battery management system. From there, you'll go into the hardware. From there, you'll go into the lower level. So that the cycle continues. I'm not going to take you through 10 levels of allocation in this presentation. You'll all sleep by then. But we're going into the DFMEA. So DFMEA, again, at every level, we could do the risk analysis. Again, the context would differ. I'm showing, by the way, the AIAG VDA format of the DFMEA. So anybody who's not so familiar, if you're looking for the 4th edition format, you're seeing the AIAG VDA. That's why it has 3 columns for functions, 3 columns for the requirements, 3 columns for the failures, right? So that's why you're seeing all of this. And then moving on. So again, I think already in Julianne's presentation in the morning, she had covered how you could have different templates. So AIGBD is one of the approaches. You can follow other ones as well. Against the functions and requirements in the left-hand side of the V model, where you have the DFMEA, you have the DBPNR on the right-hand side of the V model. That's your test plans, test records. So left side of the V model feeding to the right side of the V model. So you have every level in your left side of the V model. You can have functions, requirements, DFMEAs, etc. Right hand, you have your DBPNRs at every level. The difference is what type of information you see there. Because at integration, my focus is on interfaces. At the qualification level of testing, my focus is on primary functions and requirements, right? So the information changes as I'm going through the different levels of V model. Here's your fault tree analysis again. Another advantage is if you're already having your multi-level structured DFME in place, the failure modes already connect together and you get an FTA automatically made. So your FTA gets updated when you change your DFME. Your DFME gets updated when you update your FTA. So they're interconnected and easily updated. It's a big deal. So 2 work products, again, updating with update to one of those, right? So at any level within the structure, I can go into that and see what my failure tree looks like. So I could, and then finally I can go against my safety goal and see what are all the failures affecting, my primary safety goal there. So here's an example of going to the part 7 of, now I'm switching gears and going to manufacturing. So here's your process flow. That's showing the sequence of operations that the product must go through as it gets manufactured. So you have we're showing you an example. You can tailor the software to any set of columns, figures, or anything you want. We're showing a standard AIG example in the process flow. Here's an AIG VDA type of example when I'm getting into the process FMEA. Again, the information is interlinked. Process flow, DFMEA, control plan, work instructions are interlinked. I update one, the other gets updated. It's, again, happening seamless that way. That's what we're showing at the top right here. And then I'm going to the control plan. So control methods are updated from the PFMEA into the control plan. So again, that is automatic. You have the characteristics also showing up. And then when I'm going further down, I don't know if I'm showing the work instructions. I'm trying to recollect. I think I don't show that one in this video. But going to the next one, we're going back to the safety plan. So we covered a little bit of part 7 now in manufacturing. Now going further down, again, you're seeing all of these different artifacts. At all of these levels, you're linking those digital work products back into the main program plan. So this is one single place you can come to see all of your deliverables for functional safety. One single place. And here's process capability studies. You know, in part 7, they talk about like if you have safety characteristics, you need to have some, I don't know, Prabhu, I don't know, maybe you may have it memorized. What is the CPK value we have to hit? Is it 2 or something for significant characteristic? I don't know if somebody remembers, but it's set in the standard.
1.67.
1.6, okay, 1 point. So we got to hit that, right? So we can attach those capability studies right here. And we have inspection control module, which is, we're not going to get into that, but that's where you can do inspection studies and have that information linked back here. And in all of this, you can have the significant characteristics indicated. What is the process capability for all of that going in? And then this is another important one, getting into supplier outsourcing, right? So I have my distributed development with suppliers. Why? Because as we've seen, there might be certain activities that the supplier is doing, not me. And how can I have those artifacts again? There's actually 2 models we support. One is they can come into your program plan and have some deliverables attached. The second one is they can have a standalone version where they don't get to see anything. And they just see their own information. That's yet another option. So depending upon how your relationship with the supplier is, you can pick one of the 2 and have that done. Okay, so going forward, earlier I was showing you the timing focused view. This one is showing you work products focus. So here's a list of all the work products that is coming in, and last column is very important, quality. Every program, what are the 3 main legs of the stool that we focused on? I remember one of my colleagues calling them legs of the stool being quality, timing, and delivery, right? Sorry, timing is going with delivery, with the other one cost. Yeah. So you want to track that information here. So quality is being done manually, timing and cost is auto calculated by the system. So you get that metrics as well in a GYR format. So all of this at the end of the day is helping you create the functional safety case. That's your end. So it's like a big milestone, right? So you want to do that. So I'm going to take you to a link inside the safety case. Here's your link to the configuration management. So opening that up, it's going to take me to the configuration of work products that was available when the safety case was created. Because keep in mind, again, this could have changed over time, but when the safety case was created, this is what the configuration of work products looked like. And here's everything tied to it. So you have your hardware configuration, and you may be using, for example, GitHub for your software codes or some other software tools. You can have that link also included here, and then you can continue going down, right? So every other work product, because whenever we talk about configuration management, everybody says, oh, software. But keep in mind, system is also part of overall configuration management. You need to have the right version of the hardware and the version of the software going in together. So this is the status when the safety case was completed. You see some of these are not completed, so there's some violations there. But point is, you're seeing when that safety case was created, this is what the configuration looked like and what version it was. And we're almost at the tail end of it. Now getting into change requests. So I have all of this. How do I manage engineering change requests? That's what this one is showing to you. So you can have, this is your dashboard of all active change requests available. And then I'm going to go inside, like for example, if you look at this one, where my cursor is, So right there, we have, I think, right there, we have a change request that is an impact analysis on creating a Gen 2 of a Mercury battery pack. So part 2 of functional safety talks about impact analysis. I have a variant of a product. Now I'm going to make a new version. What changed between one and the next one? And how can I leverage my earlier work products, right? That's what we're going to show it to you here. And Going forward, this is the change form. Keep in mind, this is a digital form. We can change these fields. We want another field added, those kind of things we can do, but we already have standard templates in the tool anyway. So all you have to do is pick one of those forms, apply it. So this is what the battery pack was before. This is what I'm going to change to. What work products from my earlier PPAP changed last time. So I can even have those indicated. So these are the work products changed, and then I can also have even customer notification and everything sent. Yeah, I think so that's the end of the video, and I will just go back to my presentation. So we're coming to the tail end of it. So to tie everything together, you saw a lot of information, so many screens in the video, but how did it all tie in together? So that's what I'm going to talk about in this second last slide. So this shows you what is our score against the different parts of functional safety. So part 2, you saw safety plans. There's also audits, assessment, confirmation reviews. You already seen Madhu present audits in detail in his earlier ones. So you could do that too. And you have safety case, release for production. There's part 3 with item definition, HARA, functional safety concept. Part 4, technical safety concept, is a hardware software interface, DFMA, DVPNR test plan, FDA. Now, some of those are common to part 4, 5, and 6. The difference is one is at the system level, the other 2 are at the software and the hardware level, right? That's what part 5 and 6 is all about. And then last one is your part 7, getting into process flow diagram, PFMA control plan, and inspection information. So together, this is how we support doing, and of course, document and record control and some of those standard bells and whistles you've seen. This is how we are supporting functional safety through the EVAV platform. So key takeaways, we mentioned it quite a few times, but just in the interest of making it very clear and obvious, integrated development helps save time and makes development more efficient, right? So you can see that elimination of standalone IT systems that support development and having an integrated platform. So you don't have 10 different software platforms you're running. You have one single way to do it. That's what we're trying to offer as a value to the customers that are trying to use our EVAV platform. Use of established templates within software that guides users with their product development. This is what I was talking about, knowledge base. This is what we were talking about. You have certain defined methods of doing something. It's ingrained into the digital workflow. So you may not need 20 different work instructions to fill out a form now, because it's already going to guide you inside the tool. I got to do step 1, step 2, step 3. So that eliminates for documentation in the system that I don't need to control anymore. It's already ingrained into the tool. Then we have control workflows that ensure reviews and quality of deliverables, like we talked about. Quality, timing, and cost, right? Trying to make sure that is achieved in all programs. And lastly, reuse of information across different programs as you leverage variants and different versions of the products. And with that, here's the QR code for scanning to get some of the feedback. What do you thought about the EVAV platform? Thank you, Nikhil. Thank you.